Hey everybody, we are going to go over some superficial aspects of the brain, and maybe some interior ones, but some things that are covering and protecting the brain, like the meninges, and also some features like the gyri, sulci, and fissures. So we actually have two brains here. Here's the brain of one cadaver, and then this is half a brain of another. Let's set that aside for a second. So first thing I want to show is the dura mater. The dura mater is a very, very tough protective layer of meninges. It's very, very thick, covering the whole outside. It has two layers. There's a periosteal layer, which is more superficial, closer to the skull, continuous with the skull. And then there's a meningeal layer, which you can see that's deeper. Sometimes the two open up and you have a little passageway that forms. This is a dural venous sinus. You can see the clotted up blood here. This is a dural venous sinus. It's to drain blood away from the head to help get rid of waste from the cerebrospinal fluid. Deep to the dura mater, dura which is very, very tough, we have the arachnoid mater. Arachnoid because it's kind of spider-like, kind of web-like. You can see that the arachnoid drapes over the gyri and sulci. It does not go deep within those sulci. It's just draped over it like saran wrap. It's also covering and holding and protecting the blood vessels underneath it, deep to it. That's arachnoid mater. Arachnoid mater also has that subarachnoid space, which helps circulate the cerebrospinal fluid. If you were to peel away the arachnoid mater, then you'd see that the brain tissue will follow along those gyri and sulci, the wrinkles and the peaks. We can just assume that there is one more very, very thin layer of meninges on top of here. That's the pia mater. So pia mater is directly against the brain tissue going along with the gyri and the sulci. Arachnoid mater is draped over it. Dura mater is very, very tough. It's been cut away from most of this. You can see just fragments of it here. Dura mater. If we have two brains together, oh, one more thing I want to show. If we have two brains together, we can see that there's this fused dura mater that goes in the longitudinal fissure. You can see dura mater from one side, dura mater from the other side. The dura mater that goes in the longitudinal fissure, it's known as the falx cerebri. Falx cerebri. Falx means crescent-shaped. It's between the cerebrum. Falx cerebri. Landmarks that we can see from the outside. Once again, we can see the longitudinal fissure. Longitudinal fissure separates right from left hemispheres. This is the anterior, posterior. We can see the transverse fissure. The transverse fissure separates the cerebrum, the big wrinkly part, from the cerebellum, the back part of the brain here. Transverse fissure, longitudinal fissure. We can see this frontal lobe of the brain is separated from this temporal lobe of the brain with this sulcus. It's not as deep as a fissure, so it's known as a sulcus. This is the lateral sulcus. Lateral sulcus. Lateral sulcus again divides the temporal lobe, which has the auditory cortex, from the frontal lobe, which has a motor cortex, primary motor cortex, and there's also parietal and occipital back here. How do we tell the difference between frontal lobe and parietal lobe? We need to look for a sulcus that kind of bisects the lateral sulcus and comes all the way up to the top, almost halfway, even a little bit more than halfway. You can see this tracing here. This is a pretty deep, long sulcus. This continues on the other side and goes nearly all the way down to the corpus callosum. This is the central sulcus. This is the central sulcus. The central sulcus divides the frontal lobe from the parietal lobe. This is the precentral gyrus. The precentral gyrus houses the primary motor cortex. This is the postcentral gyrus, houses the primary somatosensory cortex. Now I wanted to quickly have a disclaimer here. These lines aren't perfect, but this is the general area where you'd find these areas, find these regions, these brain region is important for these different things, for controlling your skeletal muscles and for sensing things from your skin. So those are some of the important superficial things you should be able to see on a brain, whether it's a model or a real brain like this one.